Hi, thanks for joining us. We're here today to talk about cycle time reduction secrets, part 2. We're standing in our North American headquarters in Mason, Ohio, just north of Cincinnati, and we're in one of our Experience Center rooms, which is a part of our commitment to you, to meet you wherever you're at, to collaborate with you, and to help you. We want to make sure that we have an opportunity to answer any questions, so at the end of today's session, we'll have a Q&A. And if you look in your top right corner, there is a Q&A spot there that you can type in questions you have. Mike and I will do our best to answer those after we go through the demonstrations that we're going to show you today. So also remember that this is part 2, so you can go watch part 1, go to Makino.com, and you can find that there. Look in our events calendar. Also, you can go to our content library and find lots of other great content as well. So Mike, part 2 today. What are you going to share with us?
So talking about reducing your machining cycle time and focusing on that non-cut time, that low risk, those low risk activities, we're going to talk about specifically and show you optimizing your program, which includes a parameter change. Now, optimizing your program, we're going to talk about and show you starting and ending with features nearest the automatic tool changer. And that's going to reduce a lot of that movement from the tool changer to the actual part. Now, in addition to that, we're going to talk about the 3-axis positioning. So instead of just moving X or Y, one linear axis, we can actually move all 3 linear axes and the rotary axis at the same time. And that involves a parameter change. So when you look at the features that are closest to your ATC, what I'm talking about here, if you look graphically, on the left side of the screen, we're talking about the position 1, 2, 3, and 4 being the same part on a 4-part up fixture. The automatic tool changer is up there on the right, and you're going to move first to position 1. That is closest to your ATC. You're not going to move from your ATC all the way down to position 3 or 4. You're going to start with 1. Then you're going to work your way around that fixture, 1 to 2 to 3 to 4. Now, you're done at that B rotation. You have to rotate and perform some operations on the other side of these parts. The next part of the slide, when you rotate B 180 degrees, you're going to stay right there at that position 4, which now becomes position 1. So you're going to work your way around. You're going to go position 1, 2, 3, and end up 4, which is right next to your automatic tool changer. That's going to reduce a lot of that non-value added motion and really help to reduce and optimize the non-cut time. So talking about the parameter change, this is in reference to multi-axis positioning. Specifically, it's FANUC, however you want to pronounce it, parameter 5001, bit 0, you make that a 0. And that allows the machine to take all that code and put it all in one line. When you program that, you put it all in one line and enables you to multi-axis positioning the X, Y, Z, and B.
All at the same time.
All at the same time. And really, you're talking about parallel processing. This is one example of a parallel process versus serial. You're taking all those axes, you're moving them together, right down to get to your feature to start your cut.
Mike, thanks for all that great information, but what I'm really excited about is we're going to get to see this firsthand out on a machine, and you're going to get to see it as well. So we're going to walk out on the floor. You're going to demonstrate this for us. I'm really looking forward to it.
Let's go. So talking about program optimizing, we're going to set the stage here for this demonstration. What we're going to do is we have a pallet set up on the machine, and you got to visualize a 2-part fixture, a 2-nest fixture, one on each side. We're going to do some work on one side of each part. We're going to rotate around, do some work on the other. Now, again, this is looking at optimizing your positioning to and from the automatic tool changer. So the first one you're going to see is more a traditional way where you're going to go over to one nest, you're going to do some work, go over to another nest, rotate, and just duplicate that exact tool path. So that's the traditional way. Then the second one you're going to see is the optimized, where we start and end with the nest closest to the tool changer. Then finally, the third demonstration in this series, I'm going to show you multi-axis positioning. Now, just a note of multi-axis position, you have to be careful. You have to be careful when you're implementing rotations and positioning. You have to fully prove that out so you don't crash your machine. So let's run this first one, and then we'll pause. So coming over to the far nest, doing some work. In this program, we're just dwelling, just to simulate the work. Then position to the right nest, same thing. Rotate and duplicate that. So coming over to the left nest again. And the problem with that is most of the time, it's easy for you to duplicate that program, just going left to right, but it's not optimized. So next we're going to show the optimized version of this. We're going to start with the position closest to the ATC and end it that way. So closest nest, position over to the furthest. Now you're going to notice we're going to stay here at the rotation. We're not going to duplicate that section of the program. We stay here and do that work. And we move over to the last position, which is, again, closest to the tool changer. Now, we collected that cycle time, and we used macro variables to do that. Let me show you on the screen. So macro variable 701 represents the first demonstration, and that's the not optimized demonstration. 702 represents the optimized, starting and ending with the nest closest to the ATC. And let's see the difference here. We've got a difference of about 1.5 seconds, almost 2 seconds. Just optimizing where you start and end, closest to the tool changer. So let's move back to our program. And let's run this last demonstration. Last demonstration is the optimized motion, including multi-axis moves. Oh, look at that. All 4 axes moving at the same time. And this is where I said you have to be careful with this optimizing. Watch this one. Same thing here. When it rotates, multi-axis positioning. And then end, of course, with the position next to the ATC. And this does require the FANUC or FANUC parameter change. So let's take a look now at those macro variables, collecting those cycle times. Again, you see 701 is the non-optimized. 702 is optimized, so you start and end with the position closest to the ATC. And then 703 is the multi-axis positioning. So that's your demonstration for today. Thank you.
Thanks for doing those demonstrations for us, Mike. And if any of you would be interested in learning more about our experience centers or would like to have a one-on-one with a subject matter expert, please reach out to us. We can set that up for you. And right now, we're wanting to take some questions from you. Anything that you're wanting to know that we haven't covered yet, go to the top right corner. You'll see Q&A listed there. You go to the bottom, type in your question, and we'll be happy to answer.
Okay, so Mike, we want to, as we said, take some more questions, and we want to hear from everybody. And also, we want to start off with a simple poll just to get an idea of what people have seen in terms of multi-axis positioning and how they've thought about that. So here's the question we're going to ask them. The question is, before watching this webinar, were you aware that multi-axis positioning was possible to reduce cycle time? So we're going to give people a minute here to answer that, yes or no. You showed that demonstration. I know that some people may have known you can multi-axis position, but maybe hadn't thought about it in terms of saving cycle time and how that can affect them. So we'll be interested to see how people answer this and what they're thinking. And as we're seeing answers come in, it looks like a lot of the audience was aware of that. We've had a couple of people that were not aware of that, so that's good. They hopefully saw that today, and we can talk about it a little bit more in the Q&A as well. So yeah, so it looks like about 80% of the audience was aware that was possible, and about 20% were not aware. So Mike, with that, the multi-axis positioning, that is one of the things that I know that you said that you see that customers usually can benefit from that.
Yeah, I mean, talking about low-hanging fruit, that's a parameter change. It's a FANUC parameter, as I mentioned, the 5001. You change that parameter, and you can, especially on the G43, the tool length compensation line, you can add multi-axis positioning all on that same line.
That's right. And so I'm looking at some of the questions that we've got coming in here, and one of the questions related to multi-axis moves is asking, what is the best way to check for a potential collision when you're doing a multi-axis move? You had mentioned during the demonstration, you've got to be careful, right? You don't want to just do that and not know where your tooling, where your part is on the fixture. So this question is, how do you check for that?
Yeah, you'd absolutely have to be careful. I've seen instances where you implement the multi-axis positioning, and then you go to prove it out, and you're at 10% rapid feed rate override, just making sure that you're clearing all the features as you're positioning. And then when you go to 100%, it actually the tool actually clipped the fixture, and that was because the rotary axis acceleration deceleration is different than the linear axis. So it really starts with your simulation and your CAD CAM system. You implement multi-axis positioning in your CAD CAM system. I believe some of them support that. But then again, just stepping through, going slow, bringing up your overrides until you finally get to that 100%.
Yeah, that makes sense. And, with that in mind, we have got another poll question we're going to ask the audience now. You've got to be careful, as you said. So we're interested to know from the audience, are you concerned that a multi-axis move involves too much risk? So some of the audience may have been aware that you can do some of those methods that you talked about for checking it, but possibly they're concerned or too worried that, hey, I don't want to take that chance. So we've got that question out to the audience right now. We'll let them answer that to see if they think it's too much risk, something they don't want to do. And while we're waiting on that, let me ask you a different question that came in. Question is, are all these features available on all machines, all of Makino's machines with FANUC controls?
Yeah, I know, especially on the horizontals, certainly. Again, that's the multi-axis positioning is a FANUC. That parameter is a FANUC parameter. So yeah, it's available on all those machines, all our horizontals.
Okay.
Yep.
And so the results of our poll question is just split down the middle. About 50% think it involves too much risk, and about 50% does not think it involves too much risk. So what do you think about that, Mike?
Well, it's scary, especially the first time you do it, and you look and you run 100%. I mean, it does. It throws you back if you're not ready for it. So again, you just methodically take your time and go through and prove it out, both theoretically in the CAD CAM system and your simulator, things such as Vericut, a simulator you can use, NC simulation, and then obviously on the machine, and you'll reap the benefits of that. I mean, you saw, second and a half, 2 seconds just on that simple demonstration of a savings, and you do that across, multi rotation program and positioning, and you're gonna realize quite a bit of savings.
Another question that has to do with the multi-axis move demonstration that you showed us involves, you told us about the parameter 5001 that you've got to set, that bit 0. to 0. The question here is, what happens if it's not set to 0, but you put all the code still on the same line? What happens if you don't have that bit set to
Yeah,
0 as you specified?
unfortunately, it doesn't work, and you'll get a FANUC alarm. I think it's a tool compensation alarm. So it just won't let you do it. You have to split it out if you don't turn that parameter, enable that.
So you'll get an alarm and get notified, hey, something isn't right at that
That's right.
point. Okay.
Yep. Yep.
Okay, and one of the other parts of the demonstration you were showing us, Mike, had to do with starting and ending closest to the tool changer and the cycle time savings you can get just from doing that. Here's a question that is related to that. It says, if there is only one part on the fixture, is it worth programming features nearest the ATC first on that single part? So I guess the idea being, you were showing us a demonstration of, say, 2 parts up where you have a part on each side of the fixture. But this question is, hey, I've only got one part. Should I worry about the features that are maybe closest to the ATC versus features on that part furthest away?
Well, I mean, that depends. It depends on how large your part is. It could be some type of large housing that, takes up most of the work zone. And then certainly, starting with features closest to the ATC and kind of working your way around if you can, you're going to see the benefit of that. But, if it's a smaller part, then you may not realize such a savings trying to do that.
Yeah, okay. And one other question that just came in. This one is a little bit different, but I think we'll go ahead and touch on this. And, like we've talked about, Mike, we've got a series of webinars where we're going to be talking about a lot of different options and features for reducing cycle time. So this one might be in one of our other episodes, but let me go ahead and let you know what this audience member asked. Wants to know, would it be possible to do a tool change or positional move while the pallet is changing?
That's a good question. I believe you can do tool change during pallet change. I need to confirm that. But positional moves, no, you have to be at the pallet, the second reference position, basically the safe location with the spindle or tool before your pallet change. But I'm pretty sure you can do a tool change with a pallet change. But again, I'll follow up. We can do a follow up and confirm that.
Okay, great. Yeah, we'll do exactly that, Mike. We'll send a follow up to the person asked this question to get them clarification. And if anyone else wants clarification, reach out to us and we will contact you as well. So another question I have here, Mike, is also related to the nearest to the automatic tool changer benefit of reducing cycle time. And this question says, if I have a 4-sided fixture, what is the best way to take advantage of starting and ending nearest the ATC? So your demonstration was not a 4-sided fixture. So if you got a 4-sided fixture, how do you approach that?
Well, if you look at each side of the fixture and see, where your features are, if you have 2 parts up or what have you, you can optimize each side. And then you want to minimize your rotation. You don't want to go B0 to B180 and 270, and then, kind of look for those shortest paths to each feature in each part. And then try to end up, start with features closest, like I said, to the ATC, and then end up with features that are close to it. So, each application obviously is different, but you can certainly look at optimizing those rapid moves. And again, these are low risk things that you can do, that low hanging fruit, optimize and get all that non-cut time out as much as you can.
Right, very good. Okay, thank you, Mike. And Kevin asked the question, can a simultaneous axis move with the B axis be used on an index table machine?
Another good question. I believe so, but here's another one I need to do a follow up on. Our machines now come standard with full rotary fourth axis tables. So we don't see many indexers nowadays, but let me do a follow up on that one as well.
Okay, great. We'll make sure we get that answer to Kevin. Good. Thank you, Mike. And, You talked about in this demonstration how, we were looking at the cycle time savings. After you went through the demonstrations, you had macro variables that showed that cycle time that we were saving.
Mhm.
This question is around that. How do you do that? We talked about that in part one a little bit, but just a brief description here, if you want to tell us, how do you use macro variables to record cycle time?
Yeah, you use the system variable 3001. That's milliseconds timer. That's on all FANUC based controls. You reset that right before the activity you want to record, the motion you want to record. And then at the end of that motion or toolpath where you want to record that time, you save that to a holding type variable. That's what I like to use as a holding type variable. That way I can go back and look at that variable. It doesn't get cleared out. So that's how you do it.
Okay, perfect. And like we said, we talked a little bit more about it in part one, and that's again related to one of the other questions is how do I access the Makino content library that was mentioned? The part one previous to this is located in that content library as well as lots of other webinars and white papers and other great information. And the way you can find that is if you go to makino.com and you go to resources, you'll find content library as a selection. So that's the path you would go to find all that great information. If you have trouble finding that, reach out to us. We'll point it out to you, but hopefully you can find it easily there. And Mike, I think we're coming to the end here, but I've got I guess one more question. It's around the presentation. There were a handful of slides that you showed in the presentation. Question is, will they be available? So I just want to point out to everybody, if you go up to handouts, if you look up in your top right corner, you see handouts. If you click on that, there's actually several handouts there. One of them is the presentation slides. It says presentation handout. You can download that or view that. And there's also two other handouts there for you. There's an article handout that's available to you as well as the contact info. So feel free to take a look at those and download those and make good use of them. So Mike, we're going to wrap up. I appreciate the time, and I appreciate the time of all the audience members that came to watch this. We're looking forward to seeing you again soon. We've got part 3 coming up next month, so tune in for that, and we'll be looking forward to seeing you then. Thanks.
Yeah, thank you.